Alright, point-slope form. Now, point-slope form is a linear equation of a non-vertical line, which is the up and down line, written in the form y equals y1, or excuse me, y minus y1 equals m times x minus x1, where m is, of course, our slope, and the x1, y1 is going to be a coordinate point on this line. So here is the form. Y minus y1 equals m times x minus x1. Remember, this is your slope. These two are your coordinates. So x1, y1 is your coordinate point on the line. Alright, let's graph using point-slope form. So here's the equation I have. Y minus 5 equals 1/2 x minus 2. Okay, so the first thing is you got to identify the coordinate point x1, y1. Now, even though it's subtracting this 5 and subtracting this 2, now that's part of the form. So what it means is this 5 is a positive and this 2 is a positive. So my point is 2, 5. So that's the first thing I need to do, and I need to plot that point. So you go over 2, up 5, and here's my point, 2, 5. Okay, then the second thing is you need to use the slope. Right here is my slope, 1/2. That means up 1 over 2 to actually plot a second point. So I'm going to start from this 2, 5. I'm going to go up 1 and over 2 to plot my second point. Now, once you have these 2 points, you can draw your line, and you've got the line of your equation. And you just connected the 2 points. So let's look at the second one. We're going to graph the equation y minus 5 equals negative 2/3 x plus 2. Now we've got to identify our coordinate point. Notice right here this time, that's a positive, that's a plus. Last time it was a minus, and in our form it's a minus. So if we notice that this is a plus 2, then that 2 means it's a negative. So my coordinate point this time, since that's plus 2, is going to be negative 2. And then this is minus 5, so that's a positive 5. So I go over negative 2 and up 5, and your point is right there, negative 2, 5. Okay? Then I identify my slope, which is always going to be right in front of the parentheses. It's negative 2/3. So that means I go up 2, 1, 2, and instead of going right like I always do, I'm going to go left 3 and then get to my second point. When I plot this point, I draw a line between these 2 points, and you have the line of your equation. Alright, now writing an equation in point-slope form. This is fairly easy. All you're doing is taking the information and plugging it into a form. So we're going to write the equation of the line with the slope of negative 3. So that's my m value. That passes through the points negative 1, 7. So I'm going to take my form. Y minus y1 equals m times x minus x1. Okay? Here's my m right there. So I plug that in for m. So that's negative 3. Now my point. It goes, remember, x1, comma, y1. Okay? In the y1 is that 7. I put that right here. In the x1, that's a negative 1. I put that here. Notice I did minus negative 1. Now, I have y minus 7 equals negative 3 times x minus negative 1. Remember, keep, change, change. Keep, change, change. That's how I come up with x plus 1, is because I do the keep, change, change. And you'll always see it written more like this, with the plus 1, rather than minus a negative 1. Alright, the second one. We need to write the equation of line with slope of 2/5, so there's my m, that passes through the points 10, negative 8. So here's my x1, here's my y1. Alright, now do the same thing we did last time. Literally plug your information down and you're done. So m is 2/5. Plug that in for m. x1 is 10, so we do minus 10. y1 is negative 8, so I do minus negative 8. Now again, I have my situation of keep, change. That becomes y plus 8 over here equals 2/5 x minus 10. Notice I didn't do keep change over here to make this x plus negative 10. I just left it as x minus 10. Alright, the third one, write the equation of the line with slope 0 that passes through the point 3, 4. So that, remember, x1, y1. Okay, when I have a slope of 0, that is a horizontal line. So this is going to be a horizontal line. Alright, so y minus y1 equals m times x minus x1. So my y1 is 4, so y minus 4. My slope is 0, and then parentheses x minus x1, which is 3, so x minus 3. And this one you don't have to do any keep change or anything like that. There's your answer in point slope form right there. Very easy. Alright, another thing. If you hear passes through or contains, that means the same thing. So some of your problems on your book is going to say contained on the line, passes through the passes through the point, contains, the line contains the point, something like that. That all means the same thing. They're giving you the point for point slope. Alright, so now we're going to use 2 points to write an equation. So this first one I have 6, -4, and -3, 5. Now, we are not given our slope, but we know how to find it by doing y minus y1 over y2 minus y1 over x2 minus x1. So we find our slope using our 2 points. So 5 minus -4 and over -3 minus 6. 5 minus -4 is 9 because you do keep change. Then -3 minus 6 is -9. -9 over 9 over -9 gives you -1. Then you're going to use either point. And either point makes your point slope still correct. There's no right or wrong answer with this. As long as you use this point, your -3 with your 5, or your 6 with your -4. As long as you use one of the points that's on the line, there are several different ways you can have point slope written. Okay, so you're going to use either point. So y minus y1 equals m times x minus x1. You just found m, which was -1. Okay, if I took the second point, this point, and wrote it, I would do y minus 5 equals -1 times x plus 3, because it's a -3. So I keep change. Now if I use the first point, I get y plus 4 equals -1 times x minus 6. Both ways are correct. Even though they look different, both ways are correct. Alright, remember though, when you plug in your coordinate point, the x and y value must come from the same coordinate point, the same pair. So you're using this pair or this pair. You can't take one from each. Okay, the second one, 3, -8, and -2, 5. First thing we need to do, find slope. y2 minus y1, so 5 minus -8 is 13. And -2 minus 3, that's going to be -5. So our slope is 13 or -13 fifths is my slope. Okay? So I'm going to take that and one of the points, let's use the first point. So I'm going to go y minus y1 equals m times x minus x1. So y plus 8, if we're using this first point, equals -13 over 5, parentheses x minus 3. Or if you use this second point, -2, 5, it's going to be y minus 5 equals -13 over 5, x plus 2. Okay? Alright, now, let's see if two sets of data have a linear relationship if the rate of change, and remember that's slope, between consecutive pairs of data is the same. The rate of change, remember, is going to be our slope. Alright, so we're going to look at this. Is the relationship shown by the data linear, a straight line? And if so, we're going to model with an equation. Now, one thing you could do is plot your points and see if they follow a straight line. So make a coordinate plane and then plot your data, and if they lie on a straight line, then you know it's linear. If not, then it's not linear. Now, over here, what I did was I took my change from each one of my x's and my y's. So the difference between -1 and 3 is 4, and the difference between 4 and 6 is 2. Okay, then I'm going to do your change in y over change in x. So your change in y was 2 over your change in x was 4. So that's 1/2 for the first one. The second one, from 3 to 5 is 2 on the x side, and from 6 to 7 it's 1 on the y side. So do the y, which is 1, over the x, which is 2, and notice so far those two have the same change of rate or the same slope. Okay, now we do 5 minus 11, which changes 6, and 7 minus 10, which changes 3. So, when I do change in y over change in x, 3 over 6 simplifies to 1/2. So since all of these changes has the same rate of change of 1/2, then it's linear. So when it's linear, what you're going to do is use the slope, which is the constant rate of change, what you found here, and any one of these points to write an equation. And you're just going to write in point slope form. So y minus y1 equals m times x minus x1. So if I use this point 3, 6, I found out my rate of change was 1/2 because I found the change in between those and then the change in y over change in x. Okay, so I have y minus 6 equals 1/2 times x minus 3. And there's my equation for this set of data. It's not too hard. Alright, so graphing horizontal and vertical lines. This is something you kind of need to memorize, which would be the best way to learn it. Another way is to make note cards to remember horizontal and vertical lines. So we're going to graph y equals -3. Okay, let's just write it in standard form. That means I have no x's in here, so that means 0x. Okay, plus 1y is written. So that's really 1y equals -3. So when I have this, it's basically saying any x value I plug in, I'm going to get out a y value of -3. So I'm going to go down here to where y is -3, and I'm going to draw a horizontal line. Because no matter what x is plugged in, let's say x is 2, y is still -3, x is 0, y is still -4, or excuse me, -3, x is 6 over here, y is still -3. How about if x is -100, which would be way over here? Y is still -3. So that's why my line is a horizontal line. Now, for graphing x equals 2, that means no matter what y is, x is always going to be 2. So if I write it in standard form, I'm going to have 1x plus, since there's no y's, it's 0y, equals 2. That means all my y values, up and down, no matter what, x is going to be 2. So I plug in 2, I can get out anything for y. Now, you're going to do a vertical line on 2 right here. Remember, this is also not a function, if you remember your vertical line tests. But if you have x equals, it's a vertical line on where x equals. If you have a y equals, that means it's a horizontal line on that y-axis wherever y equals. Okay, last thing, using your x and y intercepts to graph. Alright, this is probably the quickest and easiest way to graph. So, graphing, we got 2x plus 3y equals 12. Now, my x-intercept is 2x plus 3 times 0 equals 12. You're going to solve for 12. You know what? This was on the previous video, and I just had it in my stack. So we're done after we have graphed x and y horizontal and vertical lines. I hope you enjoyed.